Okay, hello everyone. We are back to solve the exercise on inverse of a function, that is exercise 1.11. The first question, it says determine the inverse of each of the following functions. With the inverse function at the same time, it says. Okay, so the first one, A, the function f of x is the same as logarithm of 2x to the base 3. First of all, is the inverse a function, it says. So let us try to study some behavior of logarithmic function. Logarithm of x to the base a. Okay, this logarithm function always, if the base is greater than 1, the graph is just a curve passing through the point 1, 0, increasing curve, up right, down left, but the negative y-axis will be a vertical asymptote. It will never cross. That means this curve, it has no zigzag anywhere. So by horizontal line test, if you check, this curve will be crossed once. That means the function is 1 to 1 if the base is greater than 1. But the logarithm of x to the base a, when a less than 1, the number a cannot be negative. That means when I say less than 1, it has to be between 0 and 1. This time, the curve will be decreasing. It's the same passing through the point 1, 0, but it's decreasing. Up left, down right. So again, the positive y-axis will be a vertical asymptote. It will never cross the positive y-axis, both of them. So again, this curve, it will be crossed by horizontal line once. So both of them, it's 1 to 1. Generally, graph of logarithmic functions, they will be crossed once only by horizontal line test. So they are 1 to 1. You can check by another process at the same time. But this is the graph of logarithmic. So here also, the graph of this function will be crossed 1. So it's a 1 to 1 function. So it is invertible in another way. So let's find the inverse. Let's go and find directly the inverse. So how to find the inverse? The process. F of x means y is equal to logarithm of 2x to the base 3. Then in place of y, write x logarithm of 2y to the base 3. In place of x, write y, and in place of y, write x. Next step, let's clean this part. The next step, remember, for example, if you have logarithm of 8 to the base 2, if it is equal to 3, what does this mean? This is the same as 2 to the power of 3. The base here will be base for exponent also. So logarithm and exponential, they are inverse of each other. So what to do here? 2 to the power of 3. 2 to the power of 3 is the same as 8. Okay, this expression and this one are equal. They are the same. This one logarithmic form, this one exponential form. So the base for the logarithm will be the base for the exponential. So always this one, the base, if you understand this one, how to change the next step will be easier. So logarithm 8 to the base 2 is the same as 3. So that 2 to the power of 3 is equal to 8. So base for the logarithm will be base for exponent. The outcome or the result for the logarithm will be exponent for exponential. So here when I come, the 3 is the base here in the logarithm. So 3 to the power of x is equal to 2y remains, then divide by 2 both sides. When you divide by 2, the y value will be 1 over 2 times 3 to the power of x. Or you can say 3 to the power of x over 2. But the exponent x is only just for 3. So this y means, okay, don't be confused, this y means the inverse. That's what we are solving. F inverse of x will be 1 over 2 times 3 to the power of x. We are done here. So the first thing what we did, we check whether it is 1 to 1 or not. Yes, it is, because it's logarithmic function, the base greater than 1. So once we know it is 1 to 1, we just go on to find the inverse. So with the inverse, how to find the inverse, the process will be like the same as the examples that we did before. Okay. The next example, B, it's linear function, as you see. Linear functions, they are one-to-one, so we can proceed to find the inverse. And the next function, C, let's do it. It is 1 plus square root of x. But D, it is quadratic. Quadratic functions are parabolas, either upward or downward. But this time it's upward because the leading coefficient positive. Where is the vertex? Wherever it is, it's parabola, means either upward or downward. That means parabolas will be crossed twice. So it is not one-to-one. It's not invertible. It has no inverse. But let us see each of them. The first one, let's do B, which is h of x is equal to 5x plus 13. Okay, B, h of x is equal to 5x plus 13. Since linear, no need to check anything. Simply y is equal to 5x plus 3. So x is equal to 5y plus 13. I mean, it is 13. So reshuffle. X minus 13 is equal to 5y. Just I brought the 13 here, then divide both sides by 5. So x minus 13, the whole over 5 will be y. This y will be the inverse. So h inverse of x is going to be x minus 13 over 5. So that is the answer for B. Okay, let's go to D. I mean C, 1 plus square root of x. G of x is equal to C, it says g of x is equal to 1 plus square root of x. Again, in our power function lesson, we have seen square root of x. Square root of x, the graph will be like concave down. It's curving, start from the 0. It's concave down. This is the graph. What is the domain? The domain is x greater or equal to 0. What about the range? Y greater or equal to 0. This is the domain and the range. When it is 1 plus, we need to move the bending point 1 unit up. It will be the same character, but the horizontal asymptote here will be y is equal to 1. So the domain will be the set of real number, but the range y is greater or equal to 1, above 1. Here it was bended from the x-axis, but here it starts from the y equal to 1. So still it's 1 to 1. By horizontal line test, we can check it's 1 to 1 function. Therefore, let's find the inverse. Y is equal to 1 plus square root of x. Then x is equal to 1 plus square root of y. First thing, g of x means y. And then the next step is exchanging place. Interchange x and y. So in place of y, write x. In place of x, write y. Then reshuffle. X minus 1 is equal to square root of y. This one brought it here. Then the next step, to get the y, I have to square, because it is a square root. The y is found under the square root. To remove the square root, we have to think of the reverse process of inverse square root, which is a squaring. So we need to square both sides. When you square both sides, the square root cancel and y remains here. Y is equal to x minus 1 the whole square. So it's a quadratic function, we got it. It's not one-to-one, the inverse, but it is still a function. This is still a function. So this is g inverse. G inverse of x is equal to x minus 1 the whole square. That is the answer for the first one. The third example, or the third exercise, C. The last one, it is a quadratic one. It says h of x is equal to x minus 2 the whole square. As I said before, this is a quadratic function. Quadratics are always either up or downward parabola. This is upward because the coefficient is positive, as you see. It's positive number, there is no negative here. But where is the vertex? The vertex of this graph, since minus 2, like this is horizontal shifting, not vertical shifting. If it is x squared plus 2 only, we will go 2 units up directly because it's plus 2 vertical shifting it will be. But this time it's horizontal shifting. Horizontal shifting in the opposite direction. If it is minus, you have to go 2 units to the right. Horizontal. The vertex will be here and the parabola it looks like this one. So when you check by horizontal line test, it will be crossed twice. So it's not one to one. Not one to one means it's not invertible. So that the first question almost all done. That's the way how to do. Okay, we can proceed to the question number 3. Number 2, it's talking about the same line. We are asked to repeat the first one, so I skip it. Let's go to number 3. Question number 3 says, are the following functions inverse of each other, like we did previously? Two functions are inverse of each other means when you compose them, like f compose g of x, it should give you identity function, which is x. So a, what is f of x? F of x is equal to 3x plus 2. What about g of x? G of x is equal to x minus 2 over 3. Let's compose them. F of g of x. We need to get x. That means f of what is g of x? X minus 2 over 3, which is equal to okay. This is the same as f of x, don't forget it. It is 3x plus 2. F of x means 3x plus 2. If this y is going to be y. So in place, this one considered like y. So f of x is equal to 3x plus 2 means you are going to, if it is f of y, what to do? 3y plus 2. So in place of y, replace. The y is the whole thing. So what to do? 3 times x minus 2 over 3 plus 2. That means when you multiply the 3 cancel here, what left? X minus 2 plus 2 remain. So negative 2 plus 2 cancel, what left? X. So yes. Are they inverse? They are inverse. They are inverse each other. That is our conclusion. Okay, B. X cube and cube root of x. Okay, B, f of x is equal to x cube and g of x is equal to cube root of x. So again, f of y, not necessarily always f of g of x. You can say g of f of x. G of f of x is the same as g of what's f of x? X cube must be equal to g. What does the g operator do? Just put in the cube root of x cube. This is the same as x cube the power of 1 over 3. Cube root and cubing and cube root are inverse process each other, so they will cancel each other, and then simply directly you can extract x here, or if you want to express it as an exponential form, cube root means 1 over 3 the exponent. So when you multiply the 2, the 3 cancel, finally the answer will be x. In either way, finally the answer will be x, so that they are inverse each other. That means f is equal to f inverse is equal to g, you can say, or g inverse is equal to f. So they are invertible each other. Okay, the next one, square root of x and x squared. F of x is equal to square root of x and g of x is equal to x squared. Again, f of g of x is equal to f of what's g of x? X squared. This is the same as the f operator to what? Put in the square root. So square root of x squared. Square root of x squared is not directly x. The previous one, we said cube root of x cube is equal to x, we said, because cube root and cubing, they cancel each other. since it's odd function. But if it is even, if the exponent even, when you take it out, it has to be in absolute value, not only for all evens, but when we extract from this, it's even exponent and even index, they are equal. At the same time, when we extract, for example, 4 root of x to the power of 4 is the same, the absolute value of x. 6 root of x to the power of 6, it is the same, absolute value of x. But in case of odd, it's okay. For example, 5th root of x to the power of 5, when you extract just x. Or 7th root of x to the power of 7, when you extract just directly x without absolute value. Because what number square, we don't know. So the outcome will be in absolute value, not directly x. So this is not, doesn't satisfy the condition to be inverse each other. So f is not the same as, f inverse is not the same as g. Or we can say g inverse is not the same as f. So it doesn't satisfy the condition. That is answer for C. And the last one, cube root of x plus 8. Okay, f of x is equal to cube root of x plus 8. And g of x is equal to x cubed minus 8. These two are given to us. It is cube root of x plus 8. Now let's check again f of g of x, which is f of, what's g of x? X cubed minus 8, which is equal to, we have to put this whole thing in the cube root. It's the same as cube root of x cubed minus 8. So this result is not the same as, this is not the same as x. Therefore, f inverse is not the same as g, or g inverse is not the same as f. So this one doesn't work. So these are the question number 3. All we are asked to check whether the two functions are inverse each other or not. What we were doing, we were composing each other. When we compose, if the final result becomes x, we can say they are inverse each other, otherwise they are not. Okay, let's go to question number 4. Okay, the next question, question number 4, it says which one of the following functions are invertible, and if they are not, restrict the domain to make them invertible. Okay, A, it says f of x is equal to x cubed. These are odd functions. Odd functions, they are upright and downlift, passing through origin, like x cubed, x to the power of 5, generally. So they are one-to-one by horizontal like this. They are one-to-one, so invertible. On their domain, they are invertible. But B, when you come to B, it says f of g of x is equal to 4 minus x squared. It's a parabola, downward parabola, because the coefficient of x squared is negative. Where is the vertex? At 4. You can go for up, and then the graph will be downward parabola, not invertible. But to make it invertible, you have to restrict the domain. Means we need to remove one of the wing here. One of the wing. It has to be the domain. The domain must be x greater or equal to 0. This is one way. Another way, the domain must be less than or equal to 0. We can keep this one and we can remove this. This wing, we can keep it. That means the domain must be x less than or equal to 0. So to make it invertible, or to make it invertible means you have to make it one-to-one. One-to-one means we need one wing only. It was a downward parabola, remember. If I draw horizontal line, it will be crossed twice. So to make it, or to let it cross once only, I have to remove one of the wing, like I said before. So it has to be in this manner. only. That means one of the wing is x greater or equal to 0 or the other wing. So restrict the domain. We are asked to make it invertible. Either of the two works. If the domain is x greater or equal to 0 or the domain x greater or equal to 0, we can make it is invertible. So this function normally it's not invertible. But to be invertible, what must be satisfied? The domain must be x greater or equal to 0 or x less than or equal to 0. Since it was a downward parabola, we cannot take both wings, this wing and this wing. We can't take twice at the same time. Otherwise, it will be crossed twice and it's not one-to-one. So we need to keep, like graphically, it will be a clear image. You will have clear image to understand what means one-to-one. Okay. C, it is the function h of x is equal to 1 over 3x plus 5, negative 1 over 3x. So this is a linear function. Linear functions, they don't have any problem anywhere. So it is invertible. And the last one, D, it says f of x is equal to logarithm of x squared to the base 10. There is no base means common logarithm, it's base 10. This is the same as 2 times logarithm of x to the base 10. These two, like, it may increase the amplitude, but the graph will not be changed. Logarithm x to the base 10, like I told you before, it will be increasing time graph. It's a curve, just a curve. For example, passing through 1 and it's a curve still increasing because the base is 10. For example, if you insert 10 in place of x, logarithm 10 to the base 10 is 1. So when you grow 10 units somewhere around here, the outcome is 1 if there is no 2. But there is 2, that means 10 to the base 10 is 1, 1 times 2 will be 2. So the graph will be somehow increasing, somehow move up. Okay, that somehow like shifting. But the process is the same. It is passing through the point 1, 0. So the graph of logarithm x squared and logarithm x to the base 10 almost the same. The difference, it will be multiplied by 2. The outcome, every outcome will be multiplied by 2. Because this x squared, when you say it, the exponent will be a coefficient in case of logarithm. So this unit, it needs some kind of revision on exponential and logarithm because we are talking about all about functions. So those functions has to be revised. Okay, what's next? Okay, the next one is graphically. Graphically, we are asked number 5. It says which of the following are invertible. This one very simple because we were doing most of our questions by graphically. By horizontal line test, this will be crossed once, so it is invertible. And what about this? The parabola, it will be crossed twice, so it's not invertible. What about this? This curve also will be crossed once. Anywhere if you draw horizontal line, it will cross just once, so it is invertible again. This is a graph of exponential, like 2 to the power of x or 3 to the power of x, the base greater than 1, passing through 1, 0. This is a graph of quadratic. It is x squared minus 2, because the vertices are 2 units shifted down. This is a graph of exponential, but x to the power of negative 1 over 3. Okay, question number 6, it says sketch the inverse. In case of, if you remember, let's get back and revise some ideas. In case of inverse relation, we have seen R and R inverse. They are a mirror image of each other on the line y is equal to x. For example, if I have a line that is y is equal to x, and one of the graph, if it is found here like this way, the other graph must be here. Like if this is R, the R inverse will be down. They have to be inverse, like mirror image of each other. So we were even practicing, for example, like if one of the function, the graph is kind of this one, let's say this is passing point is negative 2, and this passing point, let's say it is 3, and this passing point, let's say it's 2. So how to find the inverse of, how to draw the inverse of this function? First of all, -2 and 2 in the x-axis. So you have to find -2 and 2 in the y-axis. 2 here and -2. And it's crossing the y-axis at 3 means it has to cross the x-axis at 3. When you are thinking of the inverse, exchange the place. Here it was crossing the y-axis at 3 means it should cross the x-axis at 3. And this graph crosses the x-axis at -2 and 2 means it should cross the y-axis at -2 and 2. So the graph will be it's a kind of like this. So the inverse of this function will be this one. So what to do? The x and the y-intercept points are like very critical points. Exchange them. The x-intercept, every x-intercept point will be y-intercept, and every y-intercept point will be x-intercept for the inverse. If this is a relation R, this will be R inverse. That was our previous lesson. The same, when we come to function, we are going to apply same issue. So here actually the mirror line is already given to you. So simply reflect the mirror line, this line, the middle, the broken line is y is equal to 1. Y is equal to x, I mean. Y is equal to x is mirror line. So what to do? Simply just reflect it. It was crossing at 1. Here you have to cross at 1. It crosses the y-axis at 1, as you see. So in your graph should cross the x-axis at 1. Y-intercept will be x-intercept. So does it cross the x-axis here? No. Our curve should not cross the x-axis again. Okay, when you come to here again, what are the x-intercept? 2, and the y-intercept is -2. So we have to make the y-intercept 2 and the x-intercept is -2. Here -2 will be -2 in the x. Here 2 in the x means 2 in the y it has to be. Therefore, the graph will be kind of, it's somehow going up and then it continues. Reflect, they are image of each other. Then here, when you come to here again, the mirror line is y is equal to x given to us. So try to observe. This function, it is inverse of itself. So as you see, so here the graph of this function, the last one, it is the graph of 1 over x. We can say the graph of 1 over x, function y is equal to 1 over x. So they are inverse of each other. You can check it. Let's go to another page and let's take and show you. Y is equal to 1 over x. If you have, if this is a function, how to find the inverse? X is equal to 1 over y first, then crisscross multiply, and then solve for y. So xy is equal to 1, then make y alone divided by x both sides. So y is equal to 1 over x. This is the same as f inverse of x. This was f of x. Finally, the inverse and the original function are the same. So the graph of 1 over x, it's a kind of curve, but it remains on first quadrant and third quadrant because originally y is equal to x, the graph was like a line passing through origin. So when you make it 1 over x, okay, the origin, the passing point will be detached and remain first quadrant and third quadrant. So the graph, what you see here, it is a graph of 1 over x. Okay, if you don't remember that one, even by observing, look, let's try to see. This is a mirror line. Imagine this is a mirror line. That means this curve and this curve, they are image of each other. And again, this part and this part they are image of each other. Therefore, the two functions, the function itself, it is inverse of each other. We can't draw anything here. Okay, it's drawn one function, but the inverse also itself. Because when we are trying to reflect with the line y is equal to x, the reflection is already there. This reflection wing is here. The reflection of this wing is here already. So, or as I said before, the graph of this function is y is equal to 1 over x. This graph, it represents this function. So how to find the inverse of this? The process we try to see here. Like in place of y, write x, as I did here, and in place of x, write y, and then go on the logical process. Finally, you arrive at the same result. The inverse and the original function are the same means, so that we cannot reflect, we cannot draw anything as it is remains. So these were the exercise which is found on exercise 1.10. So we are going to solve more questions from exam papers on inverse and composition of functions. So make yourself ready and try to understand any question you can ask. Thank you for watching.